So we are going to be starting chapter 3, which is going over a lot of different functions. So to start off, we're going to look at understanding quadratic functions. You should already have a deep level of understanding of this quadratics already, so you'll be applying a lot of information. So just a quick background from year 11, you should know about turning point form. And in terms of, we have our vertical shift here, which is the K, and we've got our horizontal shift, which is what's happening inside the brackets, which is our H. The dilation is looking at the number in front of our x squared. So that's everything we've gone through last year. Um, let's have a look. So we've got y equals x squared, take away 6x plus 5. So to sketch a quadratic, we need a few things. First, the turning point. Second, y-intercept. And third, our x-intercepts. So to start off, let's look at getting it into turning point form. Now, if we are trying to get it into turning point form, we're partly using the perfect square. So we are going to look at the -6, and straight away with that -6, we're going to look at halving it. So -6 divided by 2 is -3. So we're going to add -3 squared and take away -3 squared. So this first part here is our perfect square. So this is going to turn into a minus b in brackets squared, which is x minus 3 in brackets squared. Then we've got everything left over here. We just need to simplify this. So -3 squared is +9, but the negative here makes it -9, or take away 9 plus 5. Then we go -9 plus 5, which is -4. So this gives us our turning point, which is when this area here is 0, we're at -4. So we've got 3 and -4. The y-intercept's easy because we just go when y is 0, sorry, um, when x is 0, it's going to cross the y-axis. So straight away here, if x is 0, you're left with the 5 there. So it's always going to be that c value. Then if we're looking at the x-intercepts, that's where we make our y 0. So we're really using null factor law, making it 0. It makes it easier in this form because straight away we can just get x by itself. So to start off, I'm going to add 4 to both sides, and then I'm going to square it. When I square it, 4 becomes 2, but it could be positive or negative. Then I'm just going to add 3. So that gives me positive and -2 plus 3. So I've got two answers here. 2 plus 3 is 5, and -2 plus 3 is 1. So 5, 0, and 1 and 0. The next part is putting those points onto my graph and then drawing my line. Make sure that you do label each of these as a coordinate as you are graphing. Let's look at another question. So we're going to just do the same thing. It's just making sure we've got everything into our heads from last year. So we've got -2x squared plus 4x plus 1. So to start off, we will look at turning point form. So when we're doing turning point form, we really want to have a as 1. So whatever we have here, we factor out. So I'm going to divide the first two terms by -2, and I'll keep the 1 on the outside. You can double check to make sure you haven't made any mistakes. -2 times x squared is -2x squared, and -2 times -2x is +4x. So now our b value is -2. So if we halve that, it becomes -1. So we're just going to add -1 squared and take away -1 squared. So we've just made a equivalent relationship. This first part is going to be a perfect square. I put the wrong bracket here. Apologies. And that turns into x minus 1 in bracket squared. Take away 1, and then on the outside, I've still got that plus 1. We need to get rid of this -2. so we can lose one of these brackets. So to do that, I'm going to be putting the -2 in front of it here, and I'm going -2 times -1 is +2. Finally, I'm just going 2 plus 1 is 3, and I've got myself the turning point form. So when this bracket is 0, that is the turning point. So x must be 1, and therefore our y will be 3. Our y-intercept, we go straight back to the original standard form, and our c value is 1. So that c equals 1 will give us our y-intercept. The next part, we are looking at our x-intercept, so we are going to use null factor law. So I'm just making it 0. I take away 3 first from both sides. Then I'm going to divide by -2, so that will cancel out my negatives. I need to square root, and then I'm going to add 1. So we just need to be mindful that it is a positive and it is a negative answer. So when x is this, we've got a y is 0, or it could be when x is negative square root 3 over square root 2 plus 1, y is 0. If I want, I could rationalize my denominator and simplify this, but for this purpose, I am just wanting to go over the basics. So I put in all of my points that I have, and then I am able to draw my parabola. Just make sure you label each of these coordinates on your Cartesian plane. Now we get into something a bit new. This is using your understanding of parabolas in a more abstract way. So we've got find the value of k for which k plus 1 in brackets x squared plus 4kx plus 4 is a perfect square. So first thing, as soon as I see perfect square, I just wanted to write down my rule. That allows me to be able to then go, okay, what is my A, what is my B, what is my C? A is going to be k plus 1, B is going to be 4k, and C is going to be plus 4. I just paused the video quickly. I just realized I had an old equation on that where I've got my cursor right now. I just had to fix it up. Okay, so the next step, when I'm thinking about a perfect square, I'm just going to graph this on here. Okay, draw it up here. So on my Cartesian plane, if it's a perfect square, then it's going to look like this, which means I've got one intercept, so one solution. So knowing that, I'm going to use my discriminant, which is b squared minus 4ac, and it must equal 0, because if it equals 0, there's one solution. So I'm going to put in my values for b, a, and c now into this equation. So b is 4k, a is k plus 1, and c is 4. The next step that I'm going to do is I'm then going to simplify that. So 4k squared is 16k squared. Negative 4 times 4 is negative 16, so it becomes negative 16k, take away 16. Now I'm just going to want to simplify this. So the easiest way is just by looking at the first two terms, and I'm just going to factor the 16 out again, just to make it look a bit easier. I will here use complete the square. So again, I'm going, well, k is negative 1, so half that. So I'm going to be adding and taking away negative a half. And after that, I'm going to turn this part into a perfect square. So I've got this part will be a perfect square, and I'm left with take away negative a half squared. That negative a half squared turns into a quarter, and it's take away a quarter. The next part that I need to do, just need to simplify this. So if we are going to simplify, the first thing I'm going to do is get this 16 to the other side by adding, and then I'll divide by 16. So I don't need to get rid of all the brackets the normal way. I can just get rid of it slowly by getting things to the other side now. So the next step here is we've got 1 is equal to k take away a half in brackets squared, take away 1/4. So I'll get the quarter to the other side, so I'll plus it, and then I'm going to square root. So that will give me the square root of 5 over 2. Just remember this square root will be plus or minus is equal to k take away a half, and then I add a half, which gives me a plus or minus square root 5 plus 1 over 2. If we look at the next question, similar question, but instead of what we had before, it's just saying we're going to have two real solutions for x, or we're wanting one real solution. So again, we're going to go straight back to using the discriminant rule, and we are also needing to think about what does it mean to have one solution? It must be equal to 0, and if we're wanting two solutions, it must be greater than 0. We need to label what our A, B, and C are. So once we've done that, we are literally just going to substitute everything into our equation. We're going to simplify that down. So that turns into 16k squared, take away 12k. And because we've only got these two terms, I'm just going to factor out 4k. So it's 4k in brackets 4k minus 3. Let's look at one solution first. So we're practically just using our null factor law. We want it to be equal to 0. To do that, if k is equal to 0, the whole thing is, because 4 times 0 is 0. And here, if 4k minus 3 is equal to 0, then k would have to be 3 over 4. Be plus 3 divided by 4. Then if I look at two solutions, and that means it needs to be greater than 0. So the b squared minus 4ac must be bigger than 0. Again, for that to occur, we are really just thinking about what this graph will look like. And we know here it's positive, so we're going to have a minimum. So we're really saying that we want x to be less than 0, and we're saying that we want x to be greater than 3 over 4. So it's really about seeing how it's going to look on a graph. If I draw that quickly, if you're a bit confused, again, I'm not going to put the exact points in, and this is just this quadratic that I'm graphing right now. I put a point here and a point here. So say this is 0, and this here is 3 over 4. So what this is going to look like is this. So we've got two portions that are going to, two parts that is going to give us um, a, a number, an answer that is greater than 0. And if we want it to have no solutions, then we will be looking at this bottom part here. So between 0 and 3 over 4.